Christian Huygens, inspired by the Dulgreet, a large-bore cannon capable of firing a 700-pound projectile and used during the Battle of Ghent in 1411, Christian Huygens, a Dutchman, suspected that such firepower could be harnessed for non-destructive purposes. While serving as an advisor to King Louis XIV in Paris 1666 to 1681, Huygens designed a vertical cylinder similar to the barrel of a cannon, equipped with 2 buffer stops and 2 exhaust ports at the upper end, a touch hole at the lower end, and a snug-fitting piston. A rope fastened to the piston crown extended vertically to an elevated pulley system, then down to ground level, whereas was secured to a weighted platform. When fired by a small charge of gunpowder, the explosion drove the piston to the top of the cylinder against the buffer stops and exposed the exhaust ports, allowing the spent gases to escape. As pressure within the cylinder dropped, the combination of atmospheric pressure and the force of gravity impelled the piston downwards. This was actually the working stroke in which the downward pull exerted on the rope raised the weighted platform off the ground. This experiment, conducted in 1673, occurred 32 years before the appearance of the Thomas Newcomen steam engine of 1705. See Figure 1. Robert Street. In 1794, Robert Street designed a single vertical cylinder surrounded by a coal-fired preheating furnace at the lower end and a water cooling jacket at the upper end. Vertical motion of the piston was transmitted via a connecting rod and pivoted rocking beam for driving dewatering pumps in the coal mines. Prior to each power stroke, a small quantity of liquid spirits was poured into a fuel hopper connected by a supply tube to the lower end of the cylinder. A hand-operated air pump was then used to charge the cylinder with air, causing the piston to rise about 25% of its stroke. Thereafter, heat from the furnace evaporated the fuel-air mixture and produced ignition, driving the piston to the upper end of the cylinder to complete its power stroke and exert an upward push to the rocking beam. As cylinder pressure and temperature dropped, accelerated by the cooling jacket, gravity pulled the piston back down to its original position, exerting a pull on the rocking beam, which in turn operated a plunger-type pump at the other end. Jean J. Étienne Lenoir, a gas engine based on the horizontal double-acting steam reciprocating engine configuration widely used at that time, was patented in Paris, France, in 1860 by Lenoir and designed to burn a mixture of air and coal gas, ignited by an electric spark. This engine consumed approximately 100 cubic feet of gas per brake horsepower, attaining a thermal efficiency of about 4%, and rated at 2.0 kilowatts. See Figure 2. Otto Langen, an atmospheric gas engine built by 2 German engineers, Nikolaus August Otto and Eugen Langen, was awarded a gold medal at the Paris exhibition of 1867. Designed as an inverted vertical cylinder, it featured a free piston with rack and pinion ratchet-type drive between the piston and crankshaft, developing a thermal efficiency of 12% with a gas consumption of 45 cubic feet per brake horsepower. Alphonse Beau de Roches, although having patented the original concept of 4-stroke cycle engine operation in Paris, France, in 1862, Beau de Roches failed to produce any drawings or advance his theory beyond this stage. Siegfried Marcos, this Austrian engineer, designed and built a single-cylinder kerosene-burning engine in 1864 and installed it on a modified carriage. George B. Brayton, the first pressure-charged gasoline engine built in the United States, was designed by George R. Brayton of Rhode Island and demonstrated at the Centennial Exposition of 1876 in Philadelphia. Dugald Clerk, British patent No. 1089 was granted to Dugald Clerk, a Scottish engineer, for his design of a pressurized 2-stroke cycle engine demonstrated in Kilburn, England in 1878. Acknowledged by his peers in the field of thermodynamics as an outstanding engineer, he is also credited with having translated the original French patent description of Beau de Roches' 4-stroke cycle operation into English. Carl Benz. In July of 1886, Benz demonstrated his 3-wheeled dogcart on the streets of Mannheim, Germany. This vehicle was powered by his own version of a 4-stroke cycle engine featuring a magneto-ignition system developed by Robert Bosch. Subsequently, his 3-wheeled patent motorwagon was featured at the Paris exhibition of 1893. Gottlieb Daimler and Wilhelm Maybach, these 2 former associates of Nikolaus Otto, introduced a converted former horse-drawn carriage, powered by their new gasoline-powered engine in September of 1886. In 1893 they introduced a new vertical engine that soon became a popular motor vehicle prime mover. Daimler and Maybach introduced the world's first gasoline-powered truck in 1896. Herbert Ackroyd Stewart, a low-compression oil engine built by Herbert Ackroyd Stewart, a practical mechanic from Yorkshire, England, was introduced in 1890. It featured a cast-iron hot bulb built into the cylinder head that had to be preheated by a blowtorch for starting purposes, and subsequent firing strokes maintained the bulb at a temperature high enough to maintain continuous ignition of the fuel sprayed into it. Rudolf Christian Karl Diesel. Following undergraduate studies at the München Polytechnicum in 1879, Rudolf Diesel became an apprentice engine fitter at the Sulzer Brothers Engine Works, eventually acquired by Wärtsilä, in Winterthur, Switzerland, where he learned to build steam reciprocating engines and refrigeration compressors. 3 years later he received his patent No. 7241 for his compression ignition engine from the Patent Office Library in London in 1892, based on the following concept. Compressing in a cylinder pure air or other neutral gas to such an extent that the temperature hereby produced is far above the burning or igniting point of the fuel to be employed, whereupon the fuel is applied. Initially, his attempt to persuade Heinrich Buzz, managing director of Maschinenfabrik Augsburg, to build his new engine was unsuccessful, mainly due to the opposition of Joseph Krumper, the MFA chief engineer, who had just completed construction of a triple-expansion steam engine that was considered quite successful. This negativism was probably influenced by the fact that Diesel had recently published a manuscript under the title of The Theory and Construction of a Rational Beat Engine to replace steam engines and contemporary combustion engines. After Diesel reduced his originally estimated working pressure for the new compression ignition engine to a more moderate level, Heinrich Buzz agreed to build the new engine to determine the feasibility of the compression ignition theory, and a contract was signed in February 1893. Shortly thereafter Friedrich Krupp Werk decided to invest in the project, followed by an offer from Sulzer Brothers to pay him 20,000 marks per year in exchange for exclusive use of his patents in Switzerland. This was followed by a similar arrangement with Burmeister and Wain Shipyard in Copenhagen, Denmark. After several redesigns, during test runs of the new engine in 1897, burning kerosene, a compression pressure of 31.64 kg per square per centimeter was attained with a thermal efficiency of 26%, and the diesel dream became reality.